Yes, sir.
Okay, so
Yes, sir.
in today's class, let us re-emphasize what is that we have been doing by using the concept of data structures. So in that specifically, I think recording has just started now. Okay, so if there are any students who have not yet dropped the roll numbers, please do drop your roll numbers. Akshaya, you are there, 123. Can you please respond? I think there is a problem with your audio. Okay, fine. I can see your number. Maybe text. Maybe you can text. Okay, fine. Leave it. Yeah, yeah, yes, sir. Okay, fine. So let me see who are the list of absentees. Who are the list of absentees? There are 56 students who are present. 121 is absent. I think Abhigna is absent today. Then 121 is absent. And 146 and 147 both are absent. 150, no. Then 169 is absent. And Nikhil, what is your number? 146. Okay. I will consider your number, which is 146. Okay, so that means there are four students who are absent. Abhigna is present. 121, no, absent. Okay. So I'm just making a transition between this and the IDE. Now the IDE is visible. Please acknowledge, is the IDE is visible? I think today somebody has to take.
Yes, sir. Yes, sir.
Earlier, I used to hear
Yes, sir.
Akshaya's voice. Is the IDE is visible? Please respond.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Yes, sir.
Now,
Yes, sir.
okay, good. Now is the slide is visible?
Sir.
Is the
Yes,
slide
sir.
visible? Okay.
Yes, sir.
So let me also open the whiteboard. Quick recap of what we have discussed so far. We have completed stacks. So what is the definition of stack? Can anybody come in? 151 left the meeting. Okay. What is the definition of stack?
Stack is data memory in RAM which uses first in, last out, and last in, first out operations. And
Yeah.
the main functions are uh, uh, push and pop, and
Yeah.
peek is also
Yeah.
used.
Yeah.
And pop
So
and peek is
yeah,
also
that
used
is
to look at the top object.
yeah, that is correct. So make ensure that when you are asked to define what is the definition of stack, please make ensure that you are writing the technical definition. Okay, so don't say that stack is something which is something like a rack which is there, and then in that rack, if we keep mathematics book, and on the top of mathematics book, if you keep English book, and on the top of English book, if you keep C++ book, then if you want to see some book, then only C++ book is accessible because it is at the top. That is called as a stack. So fine, those are all valid examples, but it is not a technical definition. Okay, so let me again redefine what is the definition of stack. Okay, so stack is defined as the specific segment which is implemented in RAM, the specific segment which is implemented in RAM, which is nothing but the data memory, wherein it uses the scheme, of last in, first out, or first in, last out, Okay, in order to address the stack related operations. In other words, this is in simple words, stack is nothing but a data structure which is implemented in the memory or in the pre-designated memory of RAM, which uses last in first out or first in last out. Okay, so you have to write this definition only, and all other things like books, keeping the books on the rack, I mean one over the other is an example of stack. That's fine. Okay, so can somebody acknowledge, am I audible? Am I audible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
So some other examples, for example, if you take, wearing the bangles is an example of stack. Assume that you have some three color bangles, like you have one red and then one white and then one green. So assume that a girl is wearing first red bangle and then white and then green. So again, if you want to service, you have to take a bangle which is green. Okay, so all this you should not write as the answers. They are all examples for our analysis. Okay, clear? Am I clear? Clear? So in today's class, somebody respond.
Yes, sir.
Yeah.
Yes, sir.
So in today's class, what we will do is we will add a flavor of template. Okay, so we will re-implement stack. So notice that we have already completed stack with three things. We have done the implementation of stack with fixed size integer elements, and implementation of stack class with scalable integer array, and also implementation of stack class ADT with a single linked list. So notice that any of these three options can be asked with the class templates. That means you may be asked to write a C++ implementation or construct a C++ program in order to implement a generic stack for maintaining the elements in an array, with the appropriate stack related operations. Now notice that when you are asked to keep templates, you have to mandatorily use the notion of STL, where you have to attach that to the standard template library by using the syntax template class with a generic data type. Okay, clear? So therefore there are now three more additional problems which will come here. One is implementation of a generic stack class with the fixed size elements, implementation of generic stack class with the runtime scalable memory, implementation of stack class with the single linked list. Okay, so among these three implementations, implementation of stack class with the single linked list is quite rarely asked in exams. In fact, it is not asked in the exams because it will take a lot of time. Okay, because you need to maintain a linked list and then you need to attach a STL and then you have to create multiple objects and you have to throw multiple options to the user. Okay, so therefore it may not be asked in the external exams with a full question, but a segment of the code can be asked. So what we will do in today's class is we will probably take the first one. I think I'm getting a problem saying that we have a problem of connecting to a network. Can somebody respond? Is my voice is audible? Voice is not clear. Okay, let me hang on. Please respond. Am I audible now?
Yes, sir.
Yes, sir.
Okay. Am I audible now? Am I audible now? Somebody respond.
Yes, sir.
Yes, sir.
Okay, good. So in today's class, as I said, we will discuss and we will focus on implementation of generic stack class with either the fixed number of elements are with the scalable number of elements. That means implementation of stack class with the dynamic array, generic data items. Okay, and we will, which one you want me to do? Fixed size or dynamic? Let me take dynamic. Okay, so can somebody respond? Am I audible?
Yes, sir. Yes, sir.
Okay. I think this is gone. 1 minute. I made a click to Teams. Yeah. Now the slide is visible. Is the slide is visible?
Yes, sir.
Yes, sir.
Okay. Now let me open the C++ online compiler, which is a GDB compiler. 171, is it? Are you there? You are present? 171.
Yes, sir. Yes, sir. Yes,
Okay.
sir.
Okay. Okay. So is my voice is clear?
Yes, sir. Yes,
Okay.
sir.
Okay. Okay. Thank you. So what I will do is, I will take an example. I will take the implementation of dynamic array with the integers. Okay, so in the same code, I will add the implementation of stack, because otherwise I need to do everything from the scratch. So what I'm doing is, can anybody tell me in which class number did I discuss that? Is it 11 or 10? Let me open 11. Ninth? No, no, not in ninth class. C++ implementation of stack class with dynamic array. It is on 11th class. Okay, so now I am keeping that code which I have implemented on that day. Okay, so let me re-explain what is that we have done. This is the C++ implementation of stack class with the dynamic array. Is the editor is visible and my audio is audible? Can somebody respond?
Yes, sir.
Okay. So this is a
Yes,
stack
sir.
class. Yeah. So this is a stack class with this is the scalable array where integer is the specific data type and it is pointing to the top of the stack. Okay, and then n is the total number of elements which user is entering in as a part of the constructor, and then you are allocating the memory inside the constructor. Then you have push operation. So I think this is push. Okay, so then you have pop operation. So if top is less than or equal to -1, then it is a stack underflow error and you are popping, otherwise the top element. If you are asked to peek, then peeking is same as popping. Only thing is you should not delete it. You should not delete, you have to read it. Okay, and then you are displaying the stack. We are displaying the stack, and then this is the disallocation as a part of the destructor code. And then in main, we have thrown the options for push, pop, peek, display, and exit. And this is the one we have executed. This is the one we have executed in the last class, right? I can see people are leaving the meeting. If it is because of networking issue, it is fair enough, but please try to join, okay? So before we proceed further, let me run this, making sure that the environment is correct. Okay, so enter the number of elements. Let me take a stack with 5 elements. Let me start pushing the elements, maybe 1 in, oh, I'm sorry, invalid option. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Okay, so let me display. So if I am displaying, I am having 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5 are the elements. If I try to push one more thing, then you will get stack overflow. That means if I try to push, let us say 6, then you will get stack overflow error. Okay, so if you peak, you will get 5, but display, but the stack, you are not going to change. So stack will be 1, 2, 3, 4, 5. 5 will be also there. Now next is what? Let us pop. Let us make ensure that you are popping correctly. When you are popping 5 first, then display next. Pop, you will get 4, and then display is 4, right? Pop is 2. Okay, so 1, 2, 3, then again popping, which is 2. Popping is 3, and then display is 1, 2. Next again pop, then display is 1. Again pop, the display is empty. Now if you try to again pop, you will get stack underflow error. Okay, so this is what we have done in the last couple of classes. Somebody respond, am I audible?
Yes, sir.
Okay.
Yes, sir.
I'm sorry. Okay, so what we discussed is what is the definition of stack. Okay, so in this, make ensure that you are writing last in, first out, or first in, last out. Okay, next, what are the various operations which are involved in stack? What are the various operations which are involved in stack? Yes, anybody?
Push pop pick.
Yeah, it is push,
Peak.
then you
Pop,
have
peak,
pop,
pop, peak.
and then you have peak. Please remember, I'm intentionally spending a lot of time because these are very simple questions, but if you write some generic answers like stack operations means if we keep the data item, it will be on the top, it will not go down. Okay, but the point is usage of the technical words push, pop, and usage of the technical. I think somebody's microphone is on. Please make ensure that you are switching off. Okay, so usage of these technical words push, pop, and peak are available, or you have written. So that means then only it will be considered. Okay, next is what? When do you use stack? When do you use stack? Yeah, what will you write? Whenever, what will you write? There are 3 reasons.
Memory holes. No.
No. Memory holes.
Jumping to function.
Yeah,
Jumping to function.
first point is whenever there is a need to jump to specific functions to service, it has to again return back safely. Okay, so this process is called context switching. So under this, here the functions can be system built-in functions. System built-in functions as well as the user-defined functions. This is reason 1. Now reason 2, second reason is when you have larger expression,
Precedence of operators.
when you have larger expression, yeah, lengthier expressions such that you have more than two operands. Then you have to use the priority of operators in order to evaluate. So this is where you use the system stack. Now the third one is whenever you have enabled the interrupts. What interrupts? Microprocessor prawn or microprocessor specific. Microprocessor knows that these are the interrupts. Microprocessor prawn interrupts. Microprocessor prawn asynchronous interrupts. So microprocessor prawn asynchronous interrupts. If you are getting some asynchronous interrupts, okay. So if you are getting the asynchronous interrupts, then also you have to use the stack. Okay. Here. So please note that these are quite commonly asked 2 marks questions. Okay. So what we will do is, since I have already demonstrated the usage of implementation of stack ADT class for a scalable integer array, let us now reuse the same program. So this is the C++ implementation of generic stack class with dynamic array. Notice that this is very important, quite commonly asked for 5 marks. Am I audible? Are you following?
Yes, sir. Yes, sir.
Okay. So how do you
Yes, sir.
attach? Yeah, how do you attach the stack class? You have to use template.
Class template. Template
That
class.
is template class. Now, as one of the student is saying, this is another quite commonly done mistake by the students, because when you write in the exams, you don't understand that you are violating the syntax. Because many students write something like this. Instead of template class, you write class followed by template T. Now notice that this is wrong. This is a human aspect, because we write a C++ class by the keyword class. So you normally have a tendency that you will write class first and then template next. But always keep in mind that you write template first and then class next. Okay, so this is correct. Okay. Now notice that you are attaching this. This is the correct way of attaching to the STL. What is
Standard template.
standard template library? So now here you are now talking about maintaining a template. Generic array. The data type is T. So top of the
Runtime.
has to be int only, and then the n is number of elements. These are integer only. Okay, so what am I talking about? I am talking about writing an ADT generic stack class with its appropriate member functions. Notice that starting from line number 7 till line number 21 can be asked for 2 marks. That means you have to be careful in terms of writing the template class T, and then private access specifier generic data type. Okay, but this has to be integer only, because whether you use integer or floating point or character,
Correct.
the index must be always integer, and how many number of elements also must be an integer only. Okay. Now coming to push, the data item that needs to be pushed is T, and you will be returning on success 1, on error code. When you are popping, you will be popping the data item of T, and when you are peeking and you are returning the data type of T. When you are displaying the same, which is the generic data item inside the class. So this is the correct way of writing generic C++ stack class. Okay, so are you following? Notice that this has been asked many times in the external exam.
Yes, sir.
Okay. Next, let us start writing the functions. Okay, so today we will complete this, and then I will introduce what is the what is a queue and what are the various operations of queue, and why do we need to study queue. That will be my second part of today's class. Okay. Now let us start attaching the member functions. One is the default constructor. It should be template class T. Every member function needs to be explicitly attached in STL implementation, STL class implementation, and this is called dynamic casting. This is called dynamic casting. This is called dynamic polymorphic object casting. We are studying this under dynamic polymorphism. Okay, so are you following? Are you following?
Yes, sir.
Okay, so you are in default constructor. You
Yes, sir.
are how many number of generic data items you want to maintain, which is n. Now, what is the data type? Data type is t. This t can be anything. This t can be integer. This t can be floating point. This t can be anything based on the invoked object. But notice that this t has only primary data type. Okay, clear? It could be secondary data type of structures also. Okay, provided you are taking much care in terms of writing the inner attributes of your structure. Okay, so char or long, anything. So primarily, when you use the templates, you have to invoke the objects which are having the instances to the primary data types. However, secondary data types also can be invoked by appropriately writing the inner primary data types at the wrapper data types. Okay, so now you are flushing this. Now here you could probably get a doubt, how can I initialize every item as 0? Because 0 has the interpretation, or it has its representation both in integers or in float or in char or in long. Okay, so you can initialize it to 0 because character is nothing but ASCII. So 0 is nothing but 0x00, which is nothing but null. Okay, are you following? Are you following?
Yes, sir.
Okay, so next,
Yes, sir.
Yes, sir.
yeah, next is stack push operation. Again, dynamic casting. You are pushing the data type which is t. Okay, so if top is greater than or equal to n minus 1, then you are saying that it is stack overflow. Then s of top is equal to k, and then it is pushed, and then return 1, which is success. Right? That's it. Next, template class T. Please note, telling is very easy. When I'm coding it, you feel very simple. It's very simple. But don't do mistakes. Okay, and specifically when questions are asked, for example, I'm just writing a question here. Okay, so write a C++ member function implementation for push of a generic stack class. Write a C++ member function implementation for pushing or for push of a generic stack class. Means you have to write only this. Plus, you also need to write what is the stack class you are considering. That means this. Are you following? Whichever has been asked, address to that. Are you following? Am I lost?
Yes, sir.
Are you following? Can somebody?
Sir.
Yes, sir.
Yeah, fine. So let me again repeat. It will be, I mean, it looks very, very simple code, but when you start actually, put it in practice, then mistakes should not happen. Okay. So that is the reason why I insist you to start practicing, and then once you have practiced and once you have executed, then directly put it in record. Write it in record. So it will be like a continuous study. Okay. Now coming to pop, this is the data type T. T is equal to answer of S of top. If top is less than or equal to -1, then you return error code. Otherwise, you will be returning the popped data element. Next, coming to peak, again it is template class T. Okay, so dynamic cast. Okay, you are returning the top element, and at the last displaying, this is also class. Sorry, template class T. Okay, so stack, you have to keep T, then you are returning, you are printing the elements of the stack, and the destructor is again template class T. Okay, so stack, and then you are deleting all the memory which you are allocating at runtime. Clear? Am I clear? This is the implementation of stack class with the generic, which can be attached to a member function. Can be attached as a member function to the STL, standard template library. Now coming to this, you need to specifically tell this object is of which type. So let us take this as int. Now this is an object of stack that points. This is an object that holds an integer stack at runtime with n elements. Okay, and memory also is with x items. I think here I am taking it as x. Okay, so with the memory also being allocated at runtime. Okay, so similarly, if you want to invoke or maintain a separate stack, let us say with a float stack of s2, okay, so then this is also an object which is pointing, this is another object, this is another object that holds the floating points, floating point data stack at runtime with x number of elements. Am I clear? Are you following?
Yes, sir.
Okay, fine. So let us start executing this. So there is no more changes in main. Okay, so let me make one important point here. If you are asked to write or implement a generic C++ stack class, let us say it is for 3 marks, you don't need to write main. Let me repeat, you don't need to write main. Okay, you have to write the class by name stack with the generic STL syntax carefully with all member functions. On the other hand, if you are asked to implement a C++ generic stack class with dynamic array for 5 marks or for a long answer question, then you have to write main. If there is, when you are writing, if there is no adequate time, give most importance to writing the stack class and give less importance to writing the main. And in the main, you just write this main important declaration of object, Okay, so which is this fellow. Okay, and then just leave main. Now, as far as this example is concerned, I am not using stack floating point, so I'm just commenting it. I'm just commenting it, and let me start executing this program. Okay, so because I'll be using S1 only. S1 is at the time of compilation, you are not saying that S1 has the object of what data type, but at runtime you are casting it dynamically with integer data type, which is substituted to T as a part of STL mechanism. Okay, so shall I start compiling?
Yes, sir.
There are some
Yes,
errors.
sir.
Yeah, so let us go to line number 51. The return type has to be a generic data type, which has to be T, isn't it? Let me also see line number 17. Yeah, that was the mistake. Let me go to line number 64. Here also it should be the generic data type T. Okay, so let us recompile. Now enter the number of elements. Let me take 5. Let us push. Let us push 10. Let me display, which is 4. Let me again push. Let me push 20. Let us display 4 and 20, but in the top you have 20. I mean, we have displayed horizontally, but it is better to display vertically. Always stack, you better to display vertically. Okay. Are you listening? Are you following? Am I audible?
Yes,
Yes,
sir.
sir.
Okay. Next, push 30. Again push 50. See the display. Again push 50. See the display. Okay. Oh, I think I pressed 5. I think I pressed 5. Okay. I think I have to press 4. Okay. If I again try to push, sorry, pushing is 1, right? If I again try to push with, let us say 60, now you have to get stack overflow error. Similarly,
Stack overflow error.
let me display 4, displaying the contents of the stack is full. Then let me start popping. So when you pop, you are getting 50, and then let us again display 4. Again, let us pop. Let us display. Let us pop. Let us display. Let us pop. Let us display 10. Let us pop. Let us display. Stack is empty. Let us try to pop. You will get stack underflow error. Let us display stack is empty. Okay. So with this, we are done with the implementation of stack class with the template. That is a generic stack class. That is a generic stack class. Clear? Anybody has any doubts? Anybody has any doubts? Anybody has any doubts? Am I audible?
Yes, sir.
Okay. So with this, we are done with stacks, 3 implementations, where stack with the fixed size array is completed, stack with the scalable array is completed, stack with the linked list is completed, and stack with any of the 3 with template is also completed. So total 6 programs are completed. Okay. Okay. Yes or no?
Yes, sir.
Okay.
Yes, sir.
So now let us look into the aspects of queue. So as we have started in stacks, stacks, what we will do is we will understand what is the technical reason to study queue. Okay, which is the exact opposite way of dealing a stack. Sorry, yeah, opposite to that of this stack. Okay, I've just deleted that, right? Before I move into queues, I have a specific doubt. Okay, Okay, so let us reconsider the just now implemented generic class where we have implemented an object whose object name is S1, and let us also assume that you have another object S2. Okay, so let us assume that you have another object S2. So what is that you have done is probably you have implemented this part. Okay, now this is, let us assume this is your data memory. Let us assume this is your data memory. Data memory, which is RAM. Okay, so as a part of data memory, already in the data memory you have a specific segment which is used as stack and a specific segment which is used as heap. Okay, yes or no? I think I lost my signal.
Yes, sir.
I think I lost my signal. Am I audible?
Yes, sir.
Okay. Okay, so now in the program what you have done, what is the address of S1? What is the address of S1 and what is the address of S2? Is it here or is it here?
Heap.
You have written S1, use S1 and then S2, right? Where S1 is pointing to integer, you have created this with int and you have created this with float. Okay, so the question is, where is this S1 and where is this S2? Is it down or is it up? Is it here or
Heap, sir. Heap.
huh? It is in heap. Notice
Heap.
heap. Both S1 and S2 they are in heap. Then what is this stack you are talking about? What is this stack you are talking about?
System stack. System stack.
System stack. Yeah, that is correct. Just 1 minute. సార్ ఇప్పుడు నేను ఇంకో క్లాస్లో ఉన్నాను సార్, ఇంకా కాలేదు సార్, ఒక్క 15 minutes సార్, I'll call you back. Okay, so here I'm sorry I got a call, so I just responded to Ramdev sir. I was saying something. Yeah, so this is a system stack which is confined to the processor. Okay, this stack and what you have implemented is a C++ code. Okay, so that means in heap somewhere here you are storing a program. No, storing is happening somewhere. Where do you store? Where do you store? Storing is in, where do you store your program?
Data memory.
No, program
Hard
memory.
disk.
Program memory, which is,
ROM.
in our technical case we call it as ROM, but it is actually hard disk. Okay, so you are storing your program. You are storing your program somewhere in your data memory, and as a part of this program, when it is executing, by double clicking your .exe file, okay, so it is using this RAM as the address of S1 and as the address of S2, which is using your program is using, and this is being monitored by the so-called processor. This is being done by the microprocessor. Is the reasoning is clear what we have done? Okay, if you are clear with this, then we will start. What is the meaning of queue and why is it required? Okay, so in today's class, let me take another 5 to 10 minutes to explain what is the importance of queue. Yes, what is a queue? Shall I proceed before this is clear? Data memory RAM and program memory ROM. Is this clear?
Yes.
Clear?
Yes, sir.
Okay. So can I erase all this? Let me erase this. Okay. So now in order to understand Q, first point is you have to draw the memory horizontally, not in vertically. Now assume that this is your Q. Assume that this is your Q. So for our sake of easiness, we will assume that this is a Q, which is an integer Q, and let us assume this is a Q of 10 elements. Okay. So what is a queue? Queue will have two entries, two paths. One is this path where insertion is possible. The other is this path where dequeuing is possible. That means removal is done. Okay, so this is here you are calling it as insertion. And the technical name that is used whenever you are inserting a data element or anything into the queue is called as NQ. NQing. Okay, and we use NQ as the term as a member function. Okay, so we will use NQ, and NQing we will do at the left hand side. Where does the Q falls? Yeah, that is my next question. First of all, let us understand the significance of Q. Okay. Now on the other side, which is on the right hand side, you are actually removing the data item. Removing the data item or removing any entity or removing the item in the queue. So this process is called as dequeuing. This process is called as dequeuing, and we use dequeue. We use the notion of dequeue as a member function. Okay, clear? So as I said, I have a total, let us say 10 elements. This is 1, 2, 3, 4, 5, 6, 7, here 8, and then 9, 10. Okay, just size is not same. So this is my Q of 0. Okay, so I'm just using my mouse, so it's not the mouse, the touch screen of the laptop. Okay, so this is Q of 0, and this will be the last one where it is Q of 9. Q of 9. Okay, so unlike stack, the first the first difference is you have to draw the memory organization of your queue horizontally, and there will be two pointers. One is some the one is a one is both the pointers initially are pointing to the 0. Okay, so we will name those two pointers or those two offsets. The first one is front and the second one is the rear. Okay, so this is front and this is rear. So why do I need two pointers? Because whenever you are inserting, I need to have a specific control on the insertion point. And whenever you are deleting, I need to have a specific control when you are deleting. Okay, so whenever you are adding, let us say you are keeping a data item, let us say 4. Then your rear pointer will not be incremented, only front pointer will be incremented. So your front pointer will be incremented towards the left hand side, and rear pointer is always pointed to 0. rear pointer is always holding the value 0. So initially front is equal to rear is equal to -1. So when you are enqueuing a data item, then front will become 0. That means your front is pointing here now. So this will be your front. Are you following? This is your front. Now if you are again inserting, let us say you are inserting the data item 3, then again front will move from here to here. So your front is pointing here. That means front is ready to accept the data. So let us say you are keeping some element 7, then front is moving here. So always the front pointer moves. And you need to explicitly separate the rear, because when you are dequeuing 4. But dequeuing means you have to delete this 4. So once you are deleting, all the contents of your array has to shift towards right. It has to shift towards right by one element. That is called as block copy. That is called as the block copy. Okay. So therefore, what are the operations which are involved in queue? The operations which are involved in queue are enqueuing, and second is dequeuing. And third is displaying. Okay. So in dequeuing, you need to shift. You need to shift the elements by one record towards rear element. Okay. And in enqueuing, you need to insert at front. Okay, so at any given point of time, front will be always moving. I think I am only speaking. Let me listen. Are you following?
Yes, sir.
Okay, I think it is Akshaya. Okay, are you following?
Yes, sir.
Okay, good. See, this is a simple process of
Yes, sir.
Yes, sir.
this is a simple process of queue, which is technically is nothing but first in, first out. First in, first out. Okay, so first in, first out, or last in, last out. Whoever comes first will be getting service first. So I think I also forgot to mention, this is also called as service request. Service request. And this is also here is called as service response. This is called as service response. Am I clear? Am I clear?
Yes, sir.
Okay. Having said this, okay, in another 4 minutes, can you technically justify? Before justification, what will you write? What is the definition of queue? What is the definition of queue? Yes, what is the definition of queue? Okay, queue is defined as a data structure. Queue is defined as a data structure which is implemented in RAM, which is in data memory, that is in RAM. Okay, so remember, you already have in data memory, you have some portion which you are saying that as the system stack, which you are already saying that you have something is cutting here. Okay, let me go down. Okay, so you already have the data memory where you already have this system stack. Okay, so what is a queue? Queue is the portion of that, queue is the implementation of data structure which is pointed in some segment of the data memory, something like that, this here. Okay, from here to here. So here you have total 10 bytes, which is implemented in such a way that it is using the policy based code where you are servicing first in, first out, or last in, last out. Okay, so having said this, what is the technical importance of queue? What is the importance of queue? Yes, anybody? Maybe I think many of you are using chat box. Let me see what is happening in chat box. Where does queue falls under stack or heap? Now the answer is clear. It is in heap. It is not in stack. It is not in stack. What is the 20B, Nikhil? I don't understand. What is that 20B?
The 20 bytes no sir memory.
Oh, okay. Memory is 20 bytes. So total 10 records. That is correct. What you said is correct. Okay, so now what I want to understand is, where do you see the technical importance of queue? Do you recall what is the technical importance of stack? Functions, expressions, interrupts. Similarly, where do you use queue? Okay, so let me take an example. Okay, let me take an example. Implementation of or the need of queue specifically for a mobile device. Now let us assume that you are asked to implement, you are asked to work on a mobile processor. Okay, so assume that there is a processor. So let me put something like yeah, I'll keep, let me bring this down. Okay, so here there is a processor, right? This processor is connected with the data memory as well as program memory. Okay, so you have this program memory here. Program memory. So in program memory you have ROM. Now I'm talking about specifically to with inclination towards the mobile processor. Something like the smartphones that we are using in our daily life. Okay, so what are the programs which are there in your program memory? Okay, so if you observe closely, the first aspect is, okay, so the first, which is started at 0000, is nothing but your sequence of booting, that is called as the boot code, which is called as BIOS, isn't it? For example, if you are using, let us say, Motorola, then Motorola handset. So if you switch off and again if you switch on, it doesn't care whether you use WhatsApp or Facebook or whatever it is. First, it starts with the Moto. Yes or no? Similarly, Samsung. Similarly, you have Apple, iPhone. What is that code? That is called as BIOS. That is called as startup code. Yes or no? This is called as startup code. Are you following? Are you understanding what I'm trying to tell is, I'm trying to give you the technical importance of queue. Okay, so now this is the sequence of booting. This is the sequence of booting. Booting what? Sorry, this is the sequence of running your installed applications in program memory. Okay, so for time being, let us assume that I am interested to run a WhatsApp application and a Facebook application and a Gmail application. So I have these three applications, and these three applications I want this processor to do efficient scheduling. I want the processor to do efficient scheduling of these three apps. But the point is, before these three apps, are you following? Can somebody respond? Talk to me. Yes.
Yes, sir.
Okay. So first is the boot code. Without the
Yes, sir.
without the boot code, all this is nonsense. all this will come only when this is up. Only when this is up. Now, after the boot code, there is another important aspect, that is called the operating system, which you are saying that as the Android. Yes or no? So this and this part, these two parts, you cannot do anything as far as your device is concerned. Yes or no? Yes or no? Here you have Android.
Yes, sir.
Android OS, or you have whichever operating system that you are using in your handset, that OS has to boot. Now, on top of this, the operating system will now start what? Keeping or running the launching the applications which are nothing but your function pointers of your pre-installed applications. Now, these function pointers, which is a while one loop of WhatsApp, which is a while one loop of your Facebook, which is a while one loop of your Gmail. Okay, so these function pointers are nothing but those function addresses which are kept in a queue. So this is a queue. So here you have a queue, and you can also set the priority of the queue. Okay, so such that here you will get a WhatsApp, and then here next you will get Facebook, next you will get a Gmail. Now listen here. So now you carefully listen. So your program is in program memory. You have installed all these apps in your hard disk, in your ROM. Okay, but these instances, based on user clicking whether he wants to use a WhatsApp or a Facebook or a Gmail, accordingly that app is getting used. Okay, so whenever you are using, let us say, Gmail, and let us assume you have a Gmail of some 1.5 MB attachment. Okay, so and then you are trying to download a probably a video of 23 MB of capacity in WhatsApp, and then you are doing some live chat in Facebook. Okay, so there is only one processor, there is only one CPU here. There is only one CPU here. Okay, so this CPU, even though you have only one, which is running at some gigahertz of clock, isn't it? Which is running at some gigahertz of clock. Okay, this has to start scheduling this. This has to start scheduling these works. What are the works? Scheduling of these different apps. When it does it, when it is doing, our manual perception will be in such a way that you will not feel the delay between this switching between the WhatsApp and the Facebook and the Gmail. This process is called as multitasking, which is the greatest service provided by the operating system. Okay, so the point I want to emphasize here is, for doing multitasking, you use queues. For doing multitasking by the operating system, you use queues. I tried to explain the technical importance of the queues, which if we don't have, then you cannot achieve multitasking. Okay, so I'll stop. Nobody is interactive. Are you following?
Yes, sir.
Yes, sir.
Yeah. So next class we will start implementing a queue with the fixed size integers, with the front and the rear elements. Okay, with the front and the rear indices, and also we will start implementing the queue by a scalable array, and finally we will start implementing a queue using a single linked list. Okay, so I'll stop here. and then we will meet in the next class. Anybody has any doubts? Are you following?
Yes, sir.
Yes, sir.
Okay, so
Yes, sir.
everybody please do make ensure that you are executing the programs and start collaboratively, start sharing the .cpp programs in groups as well as in the WhatsApp. Okay, so keep in WhatsApp because there are your own friends who don't have access to laptop or the computers. Okay, so that they can start downloading the programs that probably you have written, because you are having other courses also to do or to study. Okay, so make ensure that you are working in a very systematic, and you are having your own strategic plan of understanding the technicality of the courses which you are currently engaged in this semester. Okay, so with this, let me stop here, and I'll. I think we have not done anything coding. I think okay. I think we have done that templates. So I'll keep that template coding. And do you need this recording also? I'll keep.
Yes, sir.
Okay, fine. So let me sign off. I think I stick to the time. Still, there is 10 more minutes. Oh, you have started leaving. 121 has came and then she has left. Okay, so the point, another point I want to emphasize is it's very easy to hear. It's very easy to hear. You feel as if it is nothing. When it comes to analysis and reasoning, okay, and when specifically as the assessor, as the assessors, when we ask the questions to you in the viva voce, okay, so you won't be in a position to answer technically. So please make ensure that you are understanding the technical aspects of the topics. Okay. So let me stop here, and I will share both the video as well as the source code of today's class. Please respond. Okay. Are you following?
Yes, sir. Yes, sir.
Okay. And Akshaya and Pradyumna or any other, please check whether did your class coordinator, I think Nagaraj sir has spoken you about the Microsoft Teams app.
Yes, sir.
Okay, so whether you are also asked to migrate towards Teams.
Not yet, sir.
Not yet. Okay, fine. Anyway, slowly you will also need to change from Cisco WebEx to Microsoft. Anyway, so let me stop recording and then let me sign off and take care. Okay, bye.